Guys, we're going to start today's lesson with looking at solving equations involving absolute values. So we've talked about absolute values previously. Just a reminder, I want you to recall that the absolute value is the distance a number is from zero on the number line. So we don't ever talk about distances in terms of negative numbers. We always talk about them in terms of positive. Again, you've never heard somebody say, I'm going to go out here on the road and I'm going to make a left and travel -3 miles. No, we just say, I'm going to go out here and go left 3 miles, or I'm going to go to the right 3 miles, however the case may be. And it's the same thing with absolute values. When I'm talking about the distance that a number is away from zero on the number line, I don't ever say that it's -6 units away from zero. I might say it's 6 units to the left because it's a -6, or it's 6 units to the right, but I don't ever say it's -6 units away from zero. So the same thing happens with absolute values. If I think about the absolute value of -6, it is a +6. The absolute value of +6 is 6 units. How far away from zero is -6 on the number line? It's 6 units away. How far away from zero is 6 units on the number line? It's 6 units away. So because the absolute value of 6 could be 6 units to the left of zero or 6 units to the right of zero, we will have two cases to consider. And this is true of every absolute value inequality. There will be two cases to consider unless there's no solution whatsoever. And we'll look at that later too. Let's look at this first one. It says, let's solve y plus 2 inside the absolute values equals 4. So I have to consider that what's inside of here could have been 4, or it could have been -4 and just came out as a +4. So we've got to look at case 1, where y plus 2 is equal to 4. And we've got to look at case 2, where y plus 2 is equal to -4. Okay, so we're going to go ahead and solve. Using our properties of equality, we know that, oops, I had to get rid of that, but it didn't work out very well. Y plus 2, I need to get rid of that +2 in order to isolate my y. To get rid of a +2, I subtract 2. 2 take away 2 is nothing. If I do that on one side of the equation, I must do that on the other to keep it balanced. So 2 take away 2 is 0. So y equals 4 take away 2, which is 2. Okay, case 2, we're going to begin it the exact same way. I want to isolate this variable. I want to get the y all by itself. So I've got to get rid of my +2. The way to get rid of +2 is to take it away. Again, property of equality says if I do it to one side of the equation, I must do the same thing to the other. So on both sides, we can see I subtracted a 2. 2 take away 2 is nothing, leaving me with the y. -4 take away 2. They're the same sign, so I'm going to add 4 plus 2 is 6 and keep that sign. So it's a -6. Okay, and I just want to look at this real quick. Let's just put some numbers on our number line. And I hope that this makes more sense by the end of the lesson. It might not make a lot of sense right now, but we're still going to go ahead and look at it. So 2, 4, 6, 8, 10. I'm going to look at -6 is here on the number line. And I've got +2. These were my two solutions that I came up with. Look at what point is halfway in between both of those. We're looking at distance. Remember, we're looking at what is that we want them to be equal distance from some number. So from here to here, there's 4 units. And from here to here, there's 4 units. I just want to point that out. We'll come back to this and it'll make more sense later. But I just wanted to point out again the fact that our solution was -6 and +2, and that this -2 is the halfway point between those two solutions that we came up with. All right, so let's look at this next one. This is really interesting because remember at the very beginning, I said that the absolute value could never be a negative number. Why can't it be a negative number? Well, absolute value is the distance it is away from something. So we can't say that whatever's inside that absolute value has a distance of -1. That doesn't make sense. So as soon as I see that I have just the absolute value symbols equal to negative number, I know that there is no solution solution to this problem. There's no point in me even taking, that should be an L, solution. There's no point in me even taking the time to bother with two cases. I cannot have an absolute value equal to a negative number. So no solution, 0 with a slash through it, the empty set. All of these represent the same thing. This problem has absolutely no solution. Those are the best kind. We don't have any work involved, right? All right, so depending on the size of each song, Leah's phone holds an average of 2,000 songs, give or take 250. You could probably stop this problem right here and come up with the answer. If my phone holds 2,000 songs, and it could hold 250 more than that, or it could hold 250 less than that, then we automatically know my phone will hold 2,250 songs, or it will hold 250 less than 2,000 would be what, 1,750 songs? But the problem didn't ask for me to just find the solution. It asked me to also write, this should be and, also, that's and, never mind, write and solve an equation involving absolute value to find the maximum. So I've got to write this equation. So this gives me the answer, but it didn't give me the equation. And the important thing here to realize is, yes, we don't need to write it out, but this helps us understand how the absolute value actually works. It helps us to see it in a real world situation. So it tells me that my phone will hold an average of 2,000 songs, give or take some. So give or take is how many, my phone will hold X number of songs, give or take 250. Okay? But it holds an average of 2,000. Well, the difference between what it holds and the average is 250. Remember, the difference is the answer to a subtraction problem. So the difference between the actual number and the average number is 250. So now we've got to make our two cases. X minus 2,000 equals 250. Or X minus 2,000 could have been negative 250. Because we know when we take the absolute value of a negative number, it comes out as a positive 250. So what was in here could have been negative 250 and just came out as a positive. So we're looking at both cases. So I'm going to add my 2,000 to both sides. So X minus 2,000 plus 2,000 equals 250. If I add 2,000 to this side to keep it balanced, I've got to add 2,000 to this side. So there it is. X equals 2,250 songs. Same thing over here. I'm just going to do it vertically because I'm running out of room. But if I add 2,000 to one side, I must add it to the other. So X equals 1,750 songs. So this proves that absolute values can help us find the solution to a problem. Maybe you end up with a problem that you don't know how to solve it right off the bat. So we can write an absolute value equation to figure it out now that we know how. So let's look at writing some absolute value equations. This ties back into what I was showing you with number 1. Remember, we're looking for values that are equal distance from some number. They're either to the right of it so many units or they're to the left of it so many units. So we're going to look at this first problem, and it says, it doesn't say anything. It's a graph. We've got a point on -2. We've got a point on +4. So let's think about the distance. What point is exactly halfway in between those two? Well, we've got 1, 2, 3, 4, 5, 6 units apart. So I know half of 6 is 3. So I'm going to look up 1, 2, 3 units. This is the distance in the middle. Okay? So I came up with that they are 3 units away. 3 units away from my X values. These are, remember when I solved my equation, I had X equals something. So this is my X value. My X equals -2, my X equals -4 when I solve it. So I've got X minus 3, right? Because it's 3 units away, or X would, I'm sorry, it's not -3. We've got X is 3 units away, so whatever I'm adding or subtracting inside of here, we haven't determined that yet, I'm sorry. but we know that it's 3 units away. So let's go back and look at that very first problem that we did. We were looking for the thing in the middle. It was 4 units away from the values that we solved for. So what we're doing when we look at the graph and writing the equation, we're obviously working backwards. So comparing it to one that we've already solved, we had -6 and +2 as our solutions. Those were each 4 units away from -2. I want you to look at this. I had a +2 and I have a -2 here. It's very interesting that both of those are 2. So let's go back down here and look. And let's try to write an equation. Okay, if I have, we know my answer is -2. So let's think about that. -2 plus or minus some number here is going to equal 3. How would I get from -2 to a +3? Think about that for a second. How do I get from -2 to +3? Your first instinct might be, say, to add 5, right? But remember, it's inside of the absolute value. So when I take whatever this solution is out, it becomes a +3. So it could be -3, it could be +3 inside of here. Well, the easiest thing to do is to get from -2 to -3, right, would be to subtract 1. That's going to give me a -3. I take the absolute value of it, and I get 3. So let's see if that -1 works with 4. Let's plug that in. 4 minus 1 gives me a 3, and the absolute value of 3 is 3. I think this equation works then, right? And notice again, I have the units apart. The average distance is 3. It was a total of 6, but the halfway point was 3 units away. So that's where this 3 came from. And then notice here I've got 1 and 1. Very interesting. So let's see if we can find a pattern, if we can come up with a generalization by looking at this over and over again. We've got 4 problems here to look at. So let's look at the next one. Our numbers are -2 and 8. So what is the halfway point between -2 and 8? Well, I come up 2, I come up 8 more, so I came a total distance of 10. We know half of 10 is 5, so if I come up 1, 2, 3, 4, 5 units, come up 1, 2, 3, 4, 5 units. This is my halfway point here. So number 3. So let's just try our theory here. Our 5 will go here. Our absolute value of x minus, let's look at this number, 3. Let's see if that works. Let's plug it in. -2 minus 3 is -5. The absolute value of -5 is 5. Worked for that. Let's look at 8. 8 minus 3 is a +5. The absolute value of +5 is 5. Hey, it worked. Let's try it again on this bottom one. Let's see how that one works. Okay, we've got, let's use blue, -5, and we've got 7. So -5 and 7. How many units are in between here? Be careful here, because I've got 2, 4, 6, 8, 10, 11, 12. I have 12 units total. We know half of 12 is 6, so I want to come up 6 units. So 1, 2, 3, 4, 5, 6. This just came up 6 units. 1, 2, 3, 4, 5, 6. This is 6 units different. So looking at our pattern, so far we've been doing x minus the number that's in the middle equals the distance apart that they are from that number, so the 6 units away from it. And that number would be what? If it's halfway between 0 and 2, it has to be 1. So let's try and see if it works. I wish that would quit popping up there on me. Okay, so looking at it, let's plug in our -5. -5 minus 1 is -6. The absolute value of -6 is 6. That works. Let's try our value of 7. 7 minus 1 is 6. The absolute value of 6 is 6. So that works. So here's my equation. So again, let's look at this one. We go up 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Again, the distance between that halfway would be 6. Halfway between there is 6. So we're going to go up 1, 2, 3, 4, 5. Up one more makes 6. And I've got 1, 2, 3, 4, 5, 6. So the absolute value of x minus that number there in the middle, which is a -3, right, should equal, how many units was it? 6? Well, let's look at this. A minus and negative is a positive. So I've got the absolute value of x plus 6 equals, plus 3 equals 6. Minus a negative becomes a positive 3. Okay, let's plug it in and check it. -9 plus 3 is -6. Absolute value of -6 is 6. It works. Let's try my 3. 3 plus 3 is 6. The absolute value of 6 is 6. So the general rule here that we just established is that we find the number of units that there are between the 2 points on our number line. We divide that in half, and that number then goes here on the end. So I'm trying to think how to say this best. The number of units that they are apart, cut in half, goes here. Then over here I have the absolute value of x minus whatever that middle point is. So if it's a positive, then it stays x minus a number. If it's a negative, then it becomes x plus a number because minus a negative is a positive. So I hope that makes sense. Again, it's the absolute value of x minus the midpoint is equal to the distance between the end point and the midpoint. So this is my midpoint. This is my endpoints. Or right here, sorry, these are my endpoints. So that is how we come up with the equation. I'm not going to probably ask you a question. I might make that a bonus question on the test because I think that's a little bit involved. And again, I've never seen that on a state test, but challenge yourself. Think big. Just because it's not on there doesn't mean we shouldn't try to challenge ourselves and try to think about things beyond the lesson. So I challenge you to think about that problem, to think about how to write an equation, and I will give you some problems to practice it just for fun because this is fun. It's like a challenge. It's like putting together a puzzle and then checking to make sure the pieces all fit and that it matched the picture at the end. So anyway, I think it's fun. Hopefully you guys find it fun, and that's all that I have for today.